Lesson number 1. Okay, so we roll a dice. This is the die. Now I don't know what to say. Dice. Okay.
I don't care.
Okay, we roll an object with numbers on it. It has 6 sides. What is the probability of getting a 1?
1 and 6.
1 out of 6. Right? If we have a spinner and we divide the spinner into 4 equal sectors, clubs, diamonds, hearts, what is the probability of getting a heart?
Quarter.
Did you grow up in Saskatchewan, by the way?
Yeah.
That's why.
Oh.
2 coins are thrown and the number of heads is counted. What is the probability of obtaining 2 heads?
Isn't that like a 1 over?
We're going to get to that. If you don't know that, we'll get to that. Okay? So not everything is as simple as the first 2. All right? Okay. A little bit of terminology, first of all. A trial, any outcome that we do. You flip a coin, that's a trial. You roll a die, that's a trial. Okay? An experiment is when you do a bunch of them together. So you flip a coin 10 times. The outcome is obviously the outcome. Heads, tails, get a 6, get a 4, whatever. The sample space is all possible outcomes. So if you're flipping a coin, you can get heads or tails. If you're rolling a die, you can get 1, 2, 3, 4, 5, 6, et cetera, et cetera. The event is the specific subset within that sample space. Okay? Yeah. Well, it doesn't have to be what you're looking for, but specific outcome. All right. So probability, if you flip a coin, heads or tails, 1 out of 2, everybody knows that. Mathematically, we would say P of A, the probability of A happening, is the number of outcomes favorable to A, i.e. the number of ways A can occur, divided by total possible outcomes. Okay? So that's why when probability of getting a 2 when you roll a die is 1 out of 6. There's 6 possible outcomes. 1 of them is favorable to what you want. If something is impossible, then it has a probability of 0. Okay? If something is certain to happen, it has a probability of 1. All right? So 1, if probability is 1, it means it's happening for sure. If it's 0, it cannot happen. So all probabilities are between 0 and 1. Okay? If you...
To turn all these into percents, you just multiply by 100%.
I believe so. The probability, I don't know if you can see it on your sheet. There should be a line over the A. That means the complement of A, i.e. A not occurring. Since all probabilities are between 1 and 0, or 0 and 1, the complement of A is 1 minus the probability of A occurring. Okay? Does that make sense? Or you can think of it as probability of A plus the probability of the complement of A, i.e. A doesn't happen, is equal to 1. It's the same formula. Okay, let's scroll down here. Let's do the last one. 2 coins are thrown. Probability of obtaining 2 heads. So, if you throw the first coin, what are your 2 outcomes? Heads or tails. That's the first coin flipped. Then you flip the coin again. What are the 2 outcomes? Heads or tails? So what's the probability of 2 heads showing up? How many ways can that happen? There's only one way, right? Right there. Right? It has to be heads and then heads. So there's one favorable outcome that we want. How many possible outcomes are there? There's 4, right? There's this one, or this one, or this one, or this one. So there's 4 different ways it can happen. So the probability is 1 in 4, or 25%. Now, the sample space is a little misleading, because if you wrote out the sample space for this, flipping 2 coins, you could have 0 heads, you could have 1 head, or you could have 2 heads. So the sample space looks like there's only 3 outcomes. All right? But when you draw it out using a tree diagram, you can see there's actually 4 outcomes. 2 of them are the same, but there's 2 ways you can get tails and heads. Yeah, that's why. Okay. Can I flip the page? Ugh. Apparently nothing is working today. Okay. All right. Now we're going to spin a spinner with numbers 1 to 3 and toss 2 coins. Okay? So, something like this, for not too complicated problems, doing a tree diagram can help out, and especially at the beginning here, but then we'll learn how to do it without the tree diagram. So, if I spin the spinner, what are the 3 outcomes? 1, 2, 3. You can get a 1, you can get a 2, or you can get a 3. That's the spinner. Then I flip 2 coins. So, each coin is heads or tails. There's the first coin flipped. Those are all my outcomes. Then you have to flip a coin again. Heads, tails. Heads, tails. You can see why you don't want to do tree diagrams for big, complex ones. Sorry? Okay, go for it. How many possible outcomes are there? A lot. A lot, says Brandon.
That's, you should put a space.
There is a space.
No, there's not.
Space. Okay. How many outcomes? There's 12 of them. There's 12 outcomes. Okay. Can anybody think of a faster way than doing what we just did?
Multiply the fractions.
I just want the outcomes.
Multiply the denominators too.
The number of outcomes of each event.
The denominator.
So there's 3 outcomes for the spinner times 2 outcomes for the first coin times 2 outcomes for the second coin. That'll give you all your possible outcomes. Are all
I think we should get
are all outcomes equally likely? Is there an unfair coin? Is there an unfair whatever? Are they or aren't they? They're all equally likely. Okay? Now, there's some repeats that will give you the same thing, but each one of these branches is equally likely to occur. That's what they mean. Okay. What's the probability of obtaining a 3 and 2 heads? So we know there's 12 possible outcomes. How many ways can I get a 3 and 2 heads? There's only one. Because you have to come down this branch right there. That'll give me the 3 and 2 heads. So there's only one way that happens, so it's 1 out of 12. What is the probability of obtaining a prime number and exactly 1 tail? So let's go back to what is a prime number. Is 1 a prime number? No, it is not. Only 2 and 3.
Oh man.
1 is not prime. So there's 12 outcomes. How many ways can you get a prime number and exactly one tail? So a 2 and then a head and a tail, that would be 1. Or you get a 2 and then a tail and a head, like that. Or you can get a 3 and a head and a tail, or a 3 and a tail and a head. So it's 4 out of 12, which is 1/3. Okay, are we okay? Does that make sense? All right. A blue die and a red die are rolled. The outcome 3 on a blue die, 4 on a red die is represented by 3, 4. So essentially, here's all the outcomes for the red die. Here's all the outcomes for the blue die. We're not going to fill in this whole thing. I think we can all deduce what each one would be. But you're going to write them as an ordered pair like this. And I can't even write the ordered pair. 1, 2, 1, 3, et cetera, et cetera. Okay? These are all the possible outcomes you can get. How many outcomes are there in the sample space? 36. Shortcut way would be 6 options on the first die, 6 options on the second die. So there's, I guess I'm writing it in the wrong spot. We really should just give up. 36. Okay. How many ways can the same number appear? No, same number on both die. It's 6 because it's going to be 1, 1, 2, 2, 3, 3, 4, 4, et cetera, et cetera, et cetera. So there's 6 ways. 6 ways that. 6 ways. Okay. So what is the probability same number appears on both die? Dice? Die? I don't know. There just is now. It's Monday. 6 out of 36, which is 1 out of 6. So there's a 1 in 6 chance that the same number will appear when you roll them. What is the probability that you get a different number on each? Yeah. It's the complement, right? It's going to be 1 minus 1 6. It's 5 out of 6. Okay. I would like you. What time does this class end?
Oh, no, that's 108.
One.
Trust me, it's Friday. No, guys.
Isn't that like? Don't we go to 3:20?
No.
No, it's Friday. This is like the last day of class.
Yeah.
Let's do 4, 5, 6, and 9. Please.
I'm gonna have to carry the notes. Yeah, I'm taking notes from Marco. That's why I filled in the whole